Now let's go to letter D. We have to find the work done by the 300 Newton force. Again, we have to remember that this 300 Newton force is not the entire force that is responsible for the movement of this cart into a 5-meter distance going rightward. So only this component here. Okay. So let's have this formula of work, which is force times distance and cosine theta. So for the force here, we will not get this force, but instead this force, because this is the force that is responsible for the movement of the cart. Okay, so that's why you have to use the Fx, or the horizontal force. And then the distance, for the distance, okay, you have to use this one. And then cosine theta, what would be the angle? So we have here, this is the direction of the force. Okay, this is the direction of force, and the distance, this is also the direction of the distance. So notice they are in the same direction, so the angle between them is 0. Okay, because they are in the same direction. Okay, so we plug this number. This is for the distance, and then cosine theta, the angle is 0 because again they are in the same direction. The horizontal force and the distance is in the same direction. They are not doing like this. That's why it has an angle. They are not doing like this because it has an angle here between them. But they are in the same direction. Therefore, the angle between them is 0. Let's get our calculator here. So we have cosine 0 times, that's 1, that times 5 times 172.07, and you get this number here. So yes, and why is it nm? Because Newton here and meters here, so if we combine, that's Newton meter. And then when you combine Newton and meter into one unit, the single unit, it becomes joules. Now take note, work is positive if the force of its component doing work is in the same direction. Just like this one, the horizontal force is going rightward and the movement of the cart is going rightward. So they are in the same direction. So a positive work aids motion. But sometimes work can be also negative if the force or its component doing work is in the opposite direction as the displacement. A negative work opposes motion. Okay, next would be we have to find the amount of friction force. So we have this formula for friction force. So we have here for friction force, and this is what we call the coefficient of kinetic friction. So this is the symbol of the coefficient of kinetic friction. And then this is the normal force. So do we have the value of the coefficient of kinetic friction? Yes, and the value is 0.30. But do we have the value of the normal force here, this one? No, we still don't have the value of the normal force. So we have to find the value of the normal force first. So how? So normal force is in the vertical direction. So we will try to look for the forces acting on the vertical direction. So we have it here, we have this one, and we have this one. Okay, this. Okay, so we have 3 forces acting in the vertical direction. So take note that the grocery cart, is not accelerating downward. It's not also flying upward. Okay? It's just in the same level. Okay, vertically, it's vertical. So therefore, we can conclude that the net force of the cart in the vertical direction is 0. Mhm. Next would be you add all the forces going upward and you subtract it to the forces going downward in order to get the net force. So let's have it here. So the normal force, it's going upward, so that's why it's positive or plus. Okay. Negative F sine theta, look for this one, the component of the applied force. It's going downward, so that's why it's minus. And also the weight here, okay? Okay, it's going downward. And the result of this is the net force. Okay, is the net force. And we are looking for the formula to get the normal force. So how can we get the formula of the normal force? So you just transfer these forces into the other side so that you will get the formula of the normal force. So it's minus, so what's the opposite of minus? That's addition. So uh, you transfer it. But before you transfer it, let's try to look first if this forces has already value. So do we have the value of the 4 sine theta? Yes, we do have the value. Do we have the value of the weight? No, we don't have the value of the weight. It isn't stated here in the problem. Do we have the value of the net force? Yes, we do have the value of the net force. How do we get 0 Newton? Based on the situation. Because again, in the vertical direction, the cart is not flying, it's not accelerating upward, or it's not accelerating downward. And we all know if the object is not accelerating in a particular direction, then we can conclude that the net force of that direction is 0. So, so only the weight, we don't have the value of the weight, so let's get the value. How? We already know this one. Weight is the product of mass times gravitational acceleration. So we have here 30 kilogram from here. It's the mass of the grocery cart. And then the G, that's 9.8 meter per second squared. And that's the constant value, the agreed value for the gravitational acceleration. Then you multiply this two, and you get this value here. This is 294 Newton. So everything is well and good. We do have the value of this one, and this one. So let's continue to transfer this. So if negative or if subtraction, the operation is subtraction. So you transfer it, it becomes addition. And the same with the weight, and the same with the net force. So just plain substitution. Okay, this one, this one. So 294 is here, and then the 0 Newton is here. Okay, and then you add, and this would be the value of the Newton. I mean the normal force. So that will be the value of the normal force, which is 539.75 Newton. So we're done with the value of the normal force, so we can solve now this friction force. So what would be the value of the friction force here? So this one, coefficient of friction 0.30, and the 539.75 Newton, that's the value of the normal force. So we can solve this problem. So just plain substitution, and let's see. Okay, 0.30 multiplied by 539.75, and you get this value here. Okay, so this will be the amount of friction force. Okay, it's going leftward because the movement is going rightward. And remember, friction always opposes motion. It's the contravida. Okay, so that's on 161.93 Newton. Mhm. Now let's go to the letter F. This is the last task. We have to find the work done by friction. Mm. So this is the friction. Is the friction doing some work with this cart here? Let's see. So we have this formula here. Work is equals to force times distance cosine theta. Now the angle here is the angle between the force and the displacement. So if we're gonna draw this, so this is the friction force going leftward, and this is, okay, that's the friction force, and this is the displacement or the distance, okay, going rightward. So the angle between them is 180 degrees. Okay, so let's simplify this formula. So the force that we are referring to here is now the friction force. And then the displacement, is this one. And then the angle is the 180 degree. Okay, because look at the diagram of between the force and the displacement. Okay, they are in opposite direction. They're forming a straight line. And then we all know that if in this case this is 180 degree. So you plug the number. We have 161.93 Newton here for friction times 5 meters, then cosine 180 degree. So let's have this calculator here. So cosine 180, that's -1 times 5 times 161.93, and you get this number here. Okay, which is negative 809.65 Newton meter. And then when you combine this one, it becomes 809.65, the same magnitude. Okay, and the unit would be joules. Okay, that's it. Okay. Now, so again, remember, work is positive. The force of its component doing work is in the same direction, okay, as the displacement. A positive work aids motion. Okay, but this time it is now negative. So work is negative if the force or its component doing work is in the opposite direction. So try to look at here. This is the friction force going leftward, and this is the displacement going rightward. Okay, a negative work opposes motion. So this one, it's really that the friction opposes the movement of the cart. Okay, so the friction is going leftward and the movement of the car is going rightward. So it always opposes the motion because it's friction.